Hello, we will be doing experiment number 10 for General Chemistry 101 lab. The title of this particular experiment is double displacement reaction. As the name suggests, double means that two anions will be displaced from their original solutions and go to the opposite cations, therefore forming a reaction and a new product. If the product is a solid, then we call the double displacement reaction as a precipitation reaction. And at the same time, knowing the concentration of the two solutions that were mixed, one can find out how much amount of the product was obtained. And whatever the product that is obtained is dried and weighed, and this is called as the actual yield because you did an experiment based on that. And just writing a balanced equation and finding out in terms of mole quantities how much mole of the product would be obtained and which compound is the limiting reagent and which compound is the excess reagent, it is possible to find out the percent yield of the compound. Remembering that in order to convert the mole of the product to the grams of the product, all you have to do is multiply by the molar mass of the product that you have. With this, I'm going to share my screen with you so that I can demonstrate the experiment. Again, it's a short experiment. And so just like any other experiment, we will go to the file, open new on the ChemLab simulation modules, go down the screen and find out the double displacement reaction, click on it. And here you show, they have, go through the introduction. It is very, very easy. You have lead nitrate solution, which is water soluble because all nitrates are water soluble. Potassium iodide is also water soluble, and therefore, because all potassium salts are water soluble, and therefore the I goes to the lead and the NO3 comes to the potassium, and you get 2NO3 AQ. AQ means it is water soluble, and therefore you can filter it off. And the lead iodide is a solid, and so we can write, and this we can write this that this is the solid that comes out. So for the procedure, we will take in what it says, get 100 ml beaker. Okay, first we go to the equipment, get 100 ml beaker. And into this 100 ml beaker, we are going to add 40. Read the procedure carefully. I'm not going to do it exactly, but you will get an idea. So add the potassium iodide, and then in the same way, get to the lead nitrate and add it. And then when you say, okay, you can see the yellow color solution and wait till all the compound is precipitated out. And that is the experiment by itself. So once the compound settles down, you have to go and get an Erlenmeyer flask with a Buckner funnel. There you have it. And then we have the Buckner funnel there. So we are going to pour and decant, get the thing so that the solid comes out of the solution. And then now click on the Buckner funnel. The Buckner funnel is highlighted. So you can either collect the solid in a beaker or in a watch glass or a test tube. So today I'm going to collect it in a beaker. So and say, okay, so there is the beaker. And then I just say, show the weight. And there, that's the amount of solid I got from my reaction. Once I get the solid, then it just fill up the observation table, Record the weight of the lead iodide. In my case, it is 4.556. Calculate the percent yield. The actual yield divided by the predicted yield times 100. So now in order to get the predicted yield, you have to multiply 20 mLs divided by 1000 mLs to get a liter and multiplied by the gram molecular weight or the molar mass of lead iodide. And so you see that you get 9.22 grams, and then the actual yield, what you get. So in my case, it would be 4.556 divided by 9.22 multiplied by 100 will give you the percentage. And with that, the experiment is over. Follow the same instructions as before. Complete the lab. Make sure you get the pictures. And then what I want you to do is complete the homework and submit it.